Okay, this is a video discussing the chemical cell, which is one part of the electrolysis, electrochemistry. So this is MCQ, Marshall Cavendish MCQ book, chapter 13. We only focus on the chemical cell for today's this session. So which of following the bulb will light up? Light up means that in the chemical cell, first condition is that the electrolyte, it must be electrolyte, must be able to have ions to conduct electricity. So in other words, this water is not a good conductor. The rest seems to be okay, aqueous. Second condition is that of course more important is that the two metal must be of different reactivity. So the only choice down here is copper and silver. Even though both they are very close, at least they're different metals, different reactivity. So therefore, the electron will flow for the more reactive metal via the external circuit through the bulb. In this case, you go this way, and the bulb will light up. All right, to the silver. Now, so what happens when electron go from copper to silver means copper will actually be oxidized. Copper will form copper 2 ion on the copper electrode side. Copper 2 ion will form oxidized. And for the silver side, there's nothing happen to my silver. The less reactive metal only provide the difference in the potential, so electron can flow towards them. But the reaction is actually involving the cation ion in the solution. So cation ion, as usual, you see that there is always hydrogen and silver. Hydrogen is from the water, aqueous. Aqueous means hydrogen. There's also silver. And silver being lower in the reactivity series, silver will selectively discharge, and therefore silver ions will be reduced and form silver metal deposited on the silver electrode itself. Yeah, so that will be the observation. Okay. Okay, next question will be question 6. All right, question 6 now here. Which statement are true comparing between electrolytic and a simple cell? Well, okay. Okay, a voltage will be generated in simple cell where both electrodes are graphite and the electrolyte is hydrochloric. Now, when electrodes are graphite, the simple cell will not be able to function anymore because simple cell must have two metals of different reactivity. All right, even if it's one is graphite, the other must be a metal of different reactivity. So the electron can flow from more reactive to a less reactive. So in this case, it cannot work. All right, so the first one is out. Electrolytic cell. Now, electrolytic cell, this is not simple cell anymore. Converts chemical into electrical energy, while simple cell converts chemical electrical, and this is true. Simple cell is the metal, the more reactive metal oxidized, and that is actually a chemical energy, chemical potential energy in the metal converted to the electron that move in the external circuit, so electrical energy. Electrolytic cells is the chemical energy. Let me see. Chemical energy, chemical energy into electrical energy in the sense that the battery itself is chemical potential energy convert to electrical energy. All right. So in this case, you realize both are the same actually. In this case, the simple cell is because of the different metal, chemical energy from different metal. Electrolytic cell is because chemical energy from the battery. Yeah. So answer 2 is correct. All right. Electron flow for anode to cathode in both cells. Let me think. Anode to cathode. Yes. Okay, because if you look at this electrolytic cell, this is plus and minus, and regardless of the electrode, like in this case, let's say it's inner electrode, you realize electron will flow out. And this side is actually the anion. For example, you just say chloride. Okay, let's say concentrated chloride. Chloride come here and donate electron. All right. So this happens at the anode. Anode is positively charged because connected to positive battery. The chloride comes here and donate electron. It is oxidized. The electron will flow from the anode into the battery. Electron flow into the cathode itself. Now, on the other hand, if you're talking about chemical cell will be two metal, for example, Mg and copper connect to a bulb. Mg being a more reactive one will be oxidized, and electron will move up. Now, basically, anode is oxidation. Now, see, oxidation of the electrode in chemical cell. Electrode oxidized in chemical cell. The anion oxidized in the electrolytic cell. So these are still anode because it's oxidized. So you realize electrons still flow from the anode to the cathode. Okay, the only difference is that if you view the electrolytic cell like this, you view this as a negative and positive pole of a battery because you're viewing this cell like a battery. So wherever electron comes out, you view it the pole as a negative. So the anode in a chemical cell is actually negative, but the anode in an electrolytic cell is positive. All right, this is positive and this is negative. Sorry, negative. So that's the difference. The difference in the positive negative, but the process is always the same. Anode is always oxidation, cathode is always reduction. So in this case, 3 is still correct. So 2 or 3 both are correct. Anode is always oxidation. You see that? Anion oxidize. This is metal oxidize. So anode is always oxidation. Anode is always a place where electron will come out, okay, to the external circuit. But because if you view this chemical cell as a battery, isn't the electron coming out means it's negative on this side, that's why electron come out. Not because of the battery, not because like, in the electrolytic cell, the battery positive actually pulls the electron out. Make it positive. Electron will come out because of the positive battery. But down here in a chemical cell, there's no battery. This being more reactive metal will produce a negative pole here, negative electrode here. Yeah. So the only difference between electrolytic and chemical is that the positive negative is opposite. And one is actually using the battery to drive the electron. The other one is actually using the two different reactivity of metals to drive the electron. Yes, oxidation is lose electron. And oxidation is always anode. Okay, because we remember oxidation, addition, memorize this way, anode is oxidation. So whenever oxidation occurs, it's called anode. So answer here looks like is 2 and 3. There's only one choice, C. So if you look carefully at the number 4, positive electrode of electrolytic cell is cathode. Positive electrolytic cell is actually the anode electrolytic cell. Positive in a simple cell is anode. Positive in the it's opposite actually. Yeah. So this one should be anode and this one should be cathode. Yeah. There we go. Okay, that was it. Okay, this question is very important, so make sure you remember. Just copy this out. Wait, make it bigger. Okay, then we'll move to the next question. This is a bit slow. Not moving. Yeah, one more time. This is crazy. Okay. Okay, so I'll just send this to you. Okay, let's go next question. All right, next question. Go down. Chemical cell. Yes, this one. Now, this one is a very good question, actually. It's a very possible exam question. It looks like something you not learned before, but it's not difficult if you read the question itself. So you must understand how does the salt bridge work. Okay, the salt bridge actually provide a connection so that you have a closed circuit, not open circuit. Without a salt bridge, nothing will happen actually. So what happens is that the salt bridge is made up of copper to manganate. They will diffuse into the electrode to maintain electrical neutrality. For example, important, when there's increase in concentration of cation, the anion in salt bridge will diffuse into that electrolyte. So if there's increase in cation on this side, then the anion will come in. All right. So let's look carefully here. What is the process here? Now, we just ignore salt bridge first. We look at the two metals, magnesium and silver. Obviously, magnesium is more reactive. Magnesium will form magnesium ion. All right. Nothing happened to my silver electrode. It is my anion that will form the metal itself. So one side will be having more cation, one side will be having less cation. Okay? All right, so let's see. What will observation connect for some time? So imagine there's an increase in concentrated cation, the anion will flow in. But you know that manganese is purple. Manganese is purple. So the cation increase. Okay. This increase. Therefore, the magnet will go in. All right. So the solution will change color. It will turn purple. Magnet is dark purple, but go to the solution, it turn to become a lighter purple. So anyway, magnet will turn purple here. So what happened to this side? Because I remove the cation, so who will come in? You have to balance neutrality, right? Where I remove the plus, some plus must come in. The copper will come in. And copper is blue. The answer is D. All right. So actually, this is a very simple question. If you read the question carefully, you know that when there is increase in positive ion, then my negative ion will come in. If there's a decrease in positive ion, then my positive ion will come in. So inside the bridge is only one positive, one negative. So magnesium will be oxidized, and therefore positive ion increase, cation increase. Therefore, anion, which is purple magnet, will come in. So therefore, A will turn purple because of magnet coming in to balance the charge. They call it electrical neutrality of the electrolyte. On the other hand, when silver is oxidized, silver is reduced because of its lower position than hydrogen. Silver is removed, then copper will come in so that to maintain the electrical neutrality, because now you make it a bit more positive to balance out again. So it turns blue. Copper is blue. And that's all for this question. Okay, this is an important question. I think I'm not sure whether I've seen this question before, but this is really a more difficult question. But if you read question in the paragraph carefully, you should be able to do it. Yeah. So this one I think is very important. Okay, let's move to the next question. This one. Have we done this? Not yet. This one looks like family. This is a very common question actually. Very, very common question. Now, when two metals are connected, whether they connect like that or through a wire, whatever, it doesn't matter. Basically, the more reactive metal will now what form the ion. So I have magnesium forming magnesium ion plus 2 electron. Now, interestingly, how does magnesium even form bubble in this case? This ion is not bubble. Bubble is because of magnesium reacting with the acid. Direct reaction in the acid. All right, direct reaction acid. So so in this case, direct reaction acid, in other words, magnesium, just imagine the reaction here is Mg plus 2H plus become Mg2 plus H2. Yes, this is a normal metal and acid reaction. So hydrogen is still discharged at the magnesium side because of the reaction with magnesium. Now magnesium is a reducing agent, right? It reduces H plus to H. In fact, metal reaction is always a redox reaction. So magnesium is oxidized while the hydrogen is reduced. So hydrogen ions are discharged. Let me see, at the magnesium rod. Is it correct? Let me see. Hydrogen ions are discharged. No, should I call it discharge? Hydrogen ions are reduced. Okay, let's look at other option first. Let me see what's this question here. Okay, let's look at the most obvious one first. Oxygen is produced at the silver rod. Oxygen produced here. Is it possible? Because electron will flow from here, electron will come out. So electron comes out means the hydrogen will form here. No, it's definitely not. It's not the oxygen gas. Okay, this is wrong. Okay, the oxygen gas is hydrogen gas rather. Because electron come out is H plus. This one confirm is the discharge of hydrogen to form hydrogen gas. Okay, so number 3 is confirmed wrong. So that means answer is not D already because there's no 3. Okay, let me see. Let's see question 1. Hydrogen gas is produced when magnesium rod as it reacts. This is correct. This is correct. This is not false. No, this is not my answer. This is correct. So answer 1 cannot be false. Answer 1 is correct. Direct reaction magnesium breathing acid is correct. So 1 cannot be my answer, so I cancel out the 1 already. So answer is C. So let me see why is this wrong. Okay, hydrogen ion. Hydrogen ions are discharged at the magnesium rod. Why is it considered wrong? Let me think. So in other words, I think they are trying to say that the discharge down here probably refers to this reaction, where you receive electron rather than through the reaction metal. Okay, it is considered as reduced. I would say this is reduced. Maybe it cannot be called, it cannot be called as a discharge, but reduced. Reduced to form hydrogen gas. Yes. So this is discharge. Perhaps we just remember that the discharge is more reserved for the electron transfer thing, for the electrolysis. Yeah. So that means 2 is wrong, 3 is wrong. Let's see number 5. Let's look at number 4. Electron flow from magnesium rod to silver rod. This is correct. This is definitely correct. All right. More reactive to less. Silver rod is a negative electrode. Silver rod is a negative electrode while the magnesium rod is positive. No, this is the opposite. Remember, the more reactive metal is always negative because electron come out from it, and this is a positive where electron goes in. Yeah, so it's 2, 3, 5. Okay, so this question is a little bit more difficult. Yes. All right, let's move to the next one. Okay. Now down here looks like this. Whenever you see a cell like that, when there's no battery, you wonder what will happen. Something will happen if there is 2 metal or different reactivity in one of the cell. Cell B has become a chemical cell. Why? Because 2 metal different reactivity in an electrolyte, the electron will flow from a more reactive metal out and then into this side. Okay, that's how you go. That's how it works. Because of different metal, zinc more reactive, electron will flow out, and so on. This side must be electrolytic cell. A must be electrolytic cell because graphite cannot be a chemical cell. So which of four is incorrect? Incorrect. Let me see. Ah. Okay, let me see. Wait. Give me a second. Where's my screen? Okay. So here, 14. Okay, so which one is incorrect? Let's see what's correct first. Figure 13.7 shows a setup of electrolytic cell. Huh? Yeah, this is electrolytic cell. This is a chemical cell. This is electrolytic. Yes, this is electrolytic cell. Cell A, the distribution. If there's no reaction in cell A with B is not connected. Of course, if not connected, there won't be any electron flow. So this is also correct. The electrolyte A decolorized after some time. This is obvious because copper is always discharged in the electrolysis setup. So it's always decolorized. So let's look at A. What PPT observed in B due to forming zinc hydroxide? Let me think. What's wrong with this? Okay, it does produce high PPT. Yes. Okay, down here, looks like everything seems to be correct. Seriously. Everyone is correct except one. One has a catch. The white PPT form will dissolve in excess sodium hydroxide. So in other words, the hydroxide being abundant here you may not have a chance to form white PPT. You form already, you dissolve away. Form already, dissolve away. Because it's excess hydroxide compared to the zinc ion. So zinc ion come out in small amount, right? So once you form zinc hydroxide, yes, white PPT. But the zinc hydroxide is amphoteric. It dissolves in the excess sodium hydroxide because sodium hydroxide is much more abundant than the zinc hydroxide. So therefore, it will dissolve. So it may stir a little bit chalky, but it will just disappear away. So it will not be a white precipitate because it's soluble in this. Unlike if it's aluminium, aluminium also can. If or lead, aluminum, and zinc, they wherever they form the hydroxide, if there is sodium hydroxide in excess, they can dissolve. Yeah. So this why PPT may not be obviously seen unless your hydroxide is very small amount and the zinc hydroxide is excess. Then the PPT can maintain. If not, it will dissolve away. So answer is A. The best answer is A. Hmm? No, here. No, okay, it's not the same. This is anode, zinc, silver, cathode. So electron will flow to this side. This is electrolytic cell, this chemical cell. So this is chemical cell, all right? And the other one is called electrolytic cell. So the chemical cell supply electrons to the electrolytic cell. And electrolysis can occur here because of this reaction. So if B is not connected, then there's no supply electron, there's no current flowing through, then electrolysis cannot happen in the electrolytic cell. Okay? Looks like every answer seems to be correct, except the A is that we need to know that zinc hydroxide is soluble in excess sodium hydroxide. So even if their form is small amount, the likelihood is that the small amount will dissolve into the hydroxide, so it will not be observed as a white precipitate. Is it okay? Okay, done already. Okay, so maybe we go to the next one. Structured questions. Which question are here? Is it here? Yeah. Okay, this one is the structured, the MC structure. Okay, MC, this is structured. This is chapter 13, structured, and FRQ. Now, some questions here are quite difficult, so let's go through this thing. Okay, here. So, explain how the setup caused the light bulb to light up. Give me a second. Go to the screen. Okay, okay. So how does it it will light up? First of all, these are two different metal. Metal has different reactivities. So the more reactive metal when connected via external circuit, the more reactive metal will first oxidize, and hence electron will move to the external circuit. Oopsie, sorry, what is happening here? Yeah. Okay. So what happens is the electron will move to external circuit, then it go one round to the less reactive metal, and the electron here will move in the electrolyte. See which is the cation. Inside here, the dilute sulfuric acid only hydrogen ion. So hydrogen ion will pick up the electron and become discharged. Nothing happened to my silver. The only thing happened is my lead will be oxidized. All right. Okay, so yeah, what's happening on my screen? What's happening on my screen? Okay, sorry. Yeah. Okay, let's see what the right answer. This is chapter 13, right? Okay, let me just take a look. Question number 3. Okay. So yeah, the answer basically says that lead is more reactive metal. Therefore, lead will lose electron. Okay, and the electron will lose electron to the silver metal. In this case, the electron will flow via the external circuit. So when it flow via the external circuit, the light bulb light up because the flow electron result in flow of current. That's electric current. Yeah, that's all. Okay. Okay, next one. Describe the change that we observe to the lead metal. Obviously, lead metal will become what? Become smaller in size. Okay, don't write lead metal oxidized. I know the chemical reaction is oxidized, but lead metal reduces in size. Okay, decrease in size. That's what you should be observing. Decrease in size. On the other hand, bubble is the other side. With the aid of a half equation, now explain whether it's oxidized or reduced. So, hmm, no, silver has nothing to do with the reaction. Silver only provide the low, uh, the less reactive electrode, right? So the electron can flow towards it. It is the hydrogen in the solution that discharge. That's why form hydrogen bubble hydrogen gas. Nothing to do with my silver. Silver only provide the potential difference. Okay, so in this case, I will say, uh, let decrease in size. Okay, basically decrease in size. And what happened is it is oxidized. Why? Because Pb will become what? Pb will become the ion. Half equation. If you can, you write the same symbol. I think all these ionic should write a symbol plus 2 electron. That's all. Okay. So using this equation, mention that it's being oxidized because of the loss of electron. Okay, oxidized because of loss of electron. Any question? No? Or you can say oxidation state of lead. Oxidation state of lead increases from 0 in Pb to plus 2, because oxidation state is a plus in front, plus 2 in Pb2 plus. That's why it's oxidized. Okay, a simple cell set up by replacing lead with magnesium. Observe that the bulb is brighter but stops shining after a very short time. Why is it so? Okay, why is magnesium producing a brighter light bulb? Yes, difference in reactive greater. In other words, the rate of flow of electron is higher rate, right? Electron will flow at a higher rate. And therefore, you light up. Then what happened next? Is my magnesium, because of that I mean, the rate of flow is higher. Yes, correct. Very good. You also react with sulfuric acid. Sorry? And therefore, you dissolve away. The electrode will basically disappear in a very short time. That's why it's a very short reaction, yes. So you should try not to use an acid if it's a reactive metal, because the metal can both oxidize in the process of redox providing electron, as well as direct reaction with the acid in contact. So therefore, you're wasting the metal actually. Yeah. Okay. In fact, the magnesium reaction is very rapid. If you use calcium, it won't work. Oh, wait. Calcium doesn't work. Because calcium and sulfuric acid form calcium sulfate, and then you form a protective layer, then reaction will stop. In fact. Lead down here, they are assuming lead can oxidize. Yes, lead will. Okay, one thing is the lead reacts slowly with acid, very slowly. Okay, very slowly with acid, so it doesn't hurt it very much. But if it's calcium react very quickly with acid to form lead sulfate, then you form a layer very fast. Okay, yeah. So predict a change in the bulb above if copper. Sorry. Yeah. Initially, yes. But once you form calcium sulfate, which is a barrier that's non-conductive, because ionic compound lead sulfate insoluble and it forms a barrier, so it's non-conducting, so that the non-conducting, so therefore it actually shield away the calcium from the electrolyte. So yeah, it become like a broken circuit. Yeah, just imagine you take the lead, put it outside the solution, hanging outside the solution. Then of course there's no complete circuit. No complete circuit means the electron will not be able to flow anymore. Okay. All right. So it's very important to realize that the electrolyte must be something to be electrolyte, it must have ions. So either dilute acids, alkalis, or salts, soluble salts inside there. There's ions. If no ions, then it doesn't form a complete circuit. If copper metal is used instead of lead, copper is nearer to silver than lead, closer, right? So basically the bulb will be dimmer, not as bright. Okay, not as bright, dimmer. Okay, that's all. All right, next one. Oh, this is a long one. Okay, so let's see what happened. Metal A, B, C, and copper. Okay. All right, let me see where they are. Metal A, metal C, metal B. The rest are all same. Okay. See whether is that a trick. Electron will flow from A to copper, C to copper. A is highest, followed by B, C, followed by B. Let me think. This could be copper to B. Copper to B. Okay, this question is a bit strange here. If they had put the B on the right hand side, like A and C, right on the right hand side, it could be a negative. It could be a negative voltage because current flow from copper to B. But down here is quite luckily that the B actually is also the lowest, also different side. So even though not negative, we know that the possibility is copper electron flow to B. B means the lowest. Okay, B could be the lowest. Okay. Because if this is not 0.4 but let's say 1, then I will wonder whether is it B lower than copper to a certain extent. See, obviously I know that my A is above C, is above copper, right? Because of these two values. Now, how about my B? Because it's on opposite side. Opposite side, and yet, you see, instead of right, left is copper, right is metal. Here is left is metal, right is copper. So does it mean that electron flow like this, it also flow like this? You see that? Because all are the same sign, all same. Because positive, negative does show the opposite direction. If they had shown a negative, it means electron flow like that. You see the point? If this anti-clockwise is positive, then the clockwise will be negative. But they didn't show negative. They didn't show negative down here could mean electron flow like this. Then it doesn't hurt because B is still below. Because this number is small, so whether B is below or copper is below, it does not matter, right? You see, if it's like that, it doesn't matter. It's still ACB because this is a small number. Okay. So by right, when you set up something like that, the positive and negative does show the direction of flow. I don't know why they put like that, B and copper. So very likely, I will say that in this case, A to copper, C to copper. Here is copper to B. But copper to B is still the smallest. It could be like that. Copper to B is still the smallest, still like that. Answer is still B, C, A. Okay? Yeah. So be careful of the positive, negative. Negative could mean the opposite direction. So for example, I change my metal A and copper. I change the metal A and copper, then it could produce a negative voltage because of the different direction of flow. Okay, describe relationship between voltage rate. I think they don't make it difficult. They just basically compare the value alone. Yeah. So that's why I put like that. Okay. If they had put a B on the right hand side, it could be a negative 0.4. But negative 0.4 simply means that it's even lower than the copper metal. Do you get it? If I swap B and copper, it could be a negative value. Okay, but in this case, it doesn't matter because B is still, no matter what, below A and C. So it's still safe. Okay? Right. Okay, let's compare A and C. If A is a very negative number, what does it mean? If A and C is identical setup, same side, C is a positive, A is negative. Negative means that it's actually below, actually go all the way down, below the copper even, if it's negative in this case. So, but it's positive, so it's high. So the negative positive could mean the flow or direction of flow electron is opposite. That's all. Okay. So describe the relationship between the voltage reading and the reactivity of the metals. Obviously, the greater the difference in reactivity, okay, the larger the voltage reading. The Q is voltage reading and reactivities of metal. So the greater the difference in the reactivities, the larger the voltage reading. Use back the same words. Okay, predict the voltage produced if A and B are used in a cell. Sorry? Okay. AC, CUB. Yes, correct. Oh, did you say that? Oh man. Okay, sorry. I missed that part. Yeah. Thanks for highlighting that. This is irritating. Then they shouldn't have changed the position like that. Yeah. Okay, anyway, there's already is like that. Thank you. They missed this part. Okay, so must read the question carefully. So in this case, if all more relative means that they don't even care about the direction, they just care about the difference only, which is of course easier. So how about A and B? Let's look at A A to copper is how much? 1.26. B to copper is 0.4. And therefore, A to B is how much? You just say 1.26 minus 0.4, right? 0.86 volt. That's all. So the sum of A to B and B to CU is A to CU. So that's how you calculate the voltage. So answer for part 3 is 0.86 because the difference between A and B is 0.86. Okay, why effervescence is observed around copper in all three cells? Now, copper is a less reactive metal. It's where the electron will come from the external circuit into the copper, and the ion has a discharge, which is sodium and hydrogen. Sodium cannot compete hydrogen. Only hydrogen can discharge because of lower position in relativity series. So I can say that in the electrolyte, there's only sodium and hydrogen ion, but hydrogen ions is discharged, selectively discharged due to lower position, okay, to form hydrogen gas, which appear as the effervescence. Okay, hydrogen ion is selectively discharged due to lower position because hydrogen is lower position, not the ion now, but the hydrogen element is lower position than sodium. Okay, better write down. Hydrogen gas, anyway, hydrogen ions is selectively discharged, okay, due to lower position in reactivity series. Discharge as hydrogen is lower in position in reactivity series compared to sodium. Okay, to form hydrogen gas that appears, that observe as effervescent. Okay, so the statement should be talking about the ion. Ion's discharge is important. Reason, hydrogen is lower in reactivity series than sodium. Form hydrogen gas that is observed as effervescence. We must explain why the effervescence. Okay, don't just say hydrogen gas, because hydrogen gas, the bubbles actually observe as effervescence. And the chemical test is very obvious, hydrogen. So basically, you just need to insert a lighted spleen, right? The Q is lighted spleen into the test tube of the gas. And the lighted spleen will extinguish, it pops out, that's all. Any question? All right, such questions, test for gas is quite often actually. But I'm not sure whether the school will test you the test for gas because it's part of QA. But student need to remember lah. Okay, let's see another question. This one I did before, right? And the rest are electrolysis, so there's no more chemical cell. I think, sorry, yeah. Okay, I guess that's all for this. Yeah, let me just stop.